Why are we studying constellations in the sky in January, you ask? Well, personally, I have found that the stars are usually a lot brighter in the wintertime than they are in the summertime. I could be wrong. Maybe I'm just not studying the stars well enough in the summertime to be correct about this. For me personally, I love it when I walk outside in the evenings and the sky is just full of sparkling lights. Yeah, it's cold, but it's still super cool. So that'll be fun for us to learn and to make our own constellations. For this experiment, all you're gonna need are toilet paper rolls, duct tape, and little paper constellations. You can find these in a book called Steam Kids, which is available here at the library. You can copy this page out of the book here at the library, and you can get your own little circles that have the pictures of the constellations already on them. But before we get to that, let's talk a little bit about stars. What is a star? Stars are giant spheres of superhot gas made up mostly of hydrogen and helium. Stars get so hot by burning hydrogen into helium in a process called nuclear fusion. This is what makes them so hot and bright. Our sun is a star. The life cycle of a star. First, there's birth. Stars start out in giant clouds of dust called nebulae. Gravity forces the dust to bunch together. As more and more dust bunches up, gravity gets stronger and it starts to get hot and becomes a protostar. Once the center gets hot enough, nuclear fusion will begin and a young star is born. Next, the main sequence star. Once a star, it will continue to burn energy and glow for billions of years. This is the state of the star for the majority of its life and is called the main sequence. During this time, a balance is met between gravity wanting to shrink the star and heat wanting to make it grow bigger. The star will remain this way until it runs out of hydrogen. Next is the red giant. When hydrogen runs out, the outside of the star expands and it becomes a red giant. Finally, it collapses. Eventually, the core of the star will start to make iron. This will cause the star to collapse. What happens to the star next depends on how much mass or how big it is. The average star will become a white dwarf star. Larger stars will create a huge nuclear explosion called a supernova. After the supernova, it may become a black hole or a neutron star. What are the different types of stars? There are so many. Stars that are in their main sequence or normal stars are categorized by their color. The smallest stars are red and don't give off much glow. Medium-sized stars are yellow, like the sun, and the largest stars are blue and are hugely bright. The larger the main sequence star, the hotter and brighter they are. Dwarf stars. Smaller stars are called dwarf stars. Red and yellow stars are generally called dwarfs. A brown dwarf is one that never quite got large enough for nuclear fusion to occur. A white dwarf is the remains of the collapsed red giant star. Giants. Giant stars may be main sequence stars like a blue giant, or stars that are expanding like red giants. Some supergiant stars are as big as the entire solar system. Neutrons. A neutron star is created from the collapse of a giant star. It is very, very tiny, but very dense. Most stars in our universe are red dwarfs. Stars twinkle because of the movement in the Earth's atmosphere. The smaller the star, the longer it'll live. Giant stars are bright, but tend to burn out fast. The nearest star to Earth is Proxima Centauri, which is about 4.2 light years away, meaning you need to travel at the speed of light for 4.2 years to get there. What are constellations? A constellation is a group of visible stars that form a pattern when viewed from Earth. The pattern they form may take the shape of an animal, a mythological creature, a man, a woman, or an object. There are 88 different constellations. These constellations divide up the entire night sky as seen from all around the world. Star maps are made of the brightest stars and the patterns that they make, which give rise to the names of the constellations. The maps of the stars represent the position of the stars as we see them from Earth. The stars in each constellation may not be close to each other at all. Some of them are bright because they are close to Earth, but others are bright because they are very large stars. Not all constellations are visible from any one point on Earth. And star maps are typically divided into maps from the Northern Hemisphere, which is North America, Europe, Asia, the upper half of Africa, and the tip of South America, and the Southern Hemisphere, which is Australia, the bottom half of Africa, most of South America, and some islands in the Pacific Ocean. The season of year can also affect what constellations are visible from where you are located on the Earth. So for our experiment, we're going to take these. Like I said, these little pictures of the constellations are available in a book here at Thornton Library. The book is called STEAM Kids and is available in our juvenile nonfiction section. You can check it out here at the library. But in this book, there is a page of constellations that are in circles like this. These circles are already the size that you need for a typical sized toilet paper roll. So it'd be really great if you were interested in making this experiment, just come to the library, get the book STEAM Kids, and copy that page out of the book so that you can get these constellations. What you're gonna do, and there's like a bunch of them on there, I just have a couple here with me, but this is what the final project is gonna look like. Basically what you're gonna do is you're gonna cut out these circles of the constellations you want. So now right now we're gonna use the Big Dipper constellation. And I'm going to tear off a strip of duct tape. I'm going to use glue because this guy, why not? Okay. And we're going to lay the duct tape flat on the table with the sticky side up. There it goes. Next, we're going to take the constellation that we want and we're going to lay it onto the tape, but we're going to have it up so that we can see the constellation. And also on this constellation, it tells you the name of the constellation you're looking at, which is going to be really helpful here at the end. So I'm going to stick this here on the tape. Stick side up just like that. So the end result is I have this. Next, I'm going to take a tack. You can take a push pin. I have a bulletin board tack here. Something that is sharp, but be careful that you don't hurt yourself. And what you're going to do is here on this constellation, you see that there are little dots that join together and create the constellation. That's where the stars are in the sky. I'm going to take my tack and I'm going to poke a hole in each of the places where the dots are. And if you want, you can use a thicker thing for a thicker pointing object for the big dots and a thinner one for the smaller stars, or you can just do all the same thing. So I'm going to take my tack and I'm going to poke a hole in each of the places where the stars are. Once again, be careful when you're doing this that you don't accidentally poke yourself. I would encourage you to ask for a parent's permission before doing this because needles, push pins, tacks, they are very sharp and I don't want anyone getting hurt. Also, you might have to unstick your duct tape a little bit here. Okay. When that's done, put this up. Now that I'm done, I should have a hole in each of the place where the star is. I'm going to make maybe some of them, you should be able to kind of see a little bit on the tape behind it. You may not be able to see it on the camera, but I can tell that I do have my hole all the way through If you're not using duct tape, I would suggest maybe doing extra layers of masking tape. Scotch tape will not work with this because what we're wanting is we want to basically block out all the light. We're basically making a bedroom planetarium, and we want to block out all the light except for what is coming through our holes here in a second. But now that we have our holes and they're well holed, we're going to take our toilet paper roll, and I'm going to stick it on the end. I'm going to lay this down here, and I want to make sure that I can see all of my stars. This one might be too small for the Big Dipper, but I can get most of it here. And when I can make sure that I have all my stars visible inside and I can see it from my toilet paper roll, I'm going to tape this nice and snug to here. I'm gonna tape down the sides a little bit here. Okay. I'm gonna get another piece of toilet paper duct tape here. There we go. And then I'm going to just kind of tape the sides around, kind of like this. And the reason I'm doing this is because I don't want any light to shine through my toilet paper, either underneath the paper or beside the paper or through the tape or anything. I want the only light to shine through is the holes that I just poked of the constellation, just like this. So now, and if you need to, you can take a tack again and you can kind of see where you had the holes, poke them there a little bit, make sure they're nice, just like that. So now what I can do is you can do two different things. You can either put this up to the light and you can see, when I put this light, you can see the light shine through the holes and you can kind of see the constellation light up like that, which is really cool. Or you can turn the lights out in your bedroom and hold your flashlight phone or your normal flashlight over the phone, over the toilet paper like this, and the light will shine through this side onto the floor, and you'll be able to see the constellation light up on your floor or light up on your wall, kind of like a shadow puppet a little bit. And that way you can see constellations and what they look like inside your house without having to go outside in the freezing cold night air. And like I said, these papers have the name of the constellation on here so that you can see, oh wait, I'm looking at the Big Dipper, or this one is, I'm looking at the Hercules constellation, or I'm looking at the Orion constellation. And I did try this experiment in my office, turn all my lights out and shine my light on the floor, and it really is cool. So I encourage you guys, try this out, study the stars, go outside and see the night sky, because it is a beautiful thing to see. Thank you everyone for joining me today, and I hope to see you guys again in the library soon. Bye!